Hi guys! People were asking how to protect the oscilloscope and how to not blow the oscilloscope. Guys, this is not about to learn a trick how to protect the oscilloscope. This video is going to be about how to learn to make electrical connections. Then you will understand how to protect the oscilloscope. Follow me in this video and we are going to learn together how to make the electrical connections to protect the oscilloscope. When a fabricant makes an oscilloscope, it makes the oscilloscope and it comes with a power cable. And the power cable has the ground connection. And for some reason, it's very important to keep the ground connection. Guys, let's be smart. There is not a switch off to turn off the ground. There is not a screw to remove the ground. It's fixed. For some reason, the fabricant thinks it's very important to keep the ground in the chassis. So let's break down right now the first taboo. YouTubers, the gurus, say the first thing you have to do is to remove the ground. That's a big mistake. For some reason, it's very important the ground to be there, and for some reason, it's fixed for you to do not remove it. Got it? Now, I'm going to connect this oscilloscope. And the multimeter is on. One wire goes to the ground connection and the other wire goes to the chassis ground. There are 8 millivolts drop between this point and this other. Next thing I'm going to do is to remove the ground connection by using an adapter. Wow, now we realize the oscilloscope is floating. And when the oscilloscope is floating, we get difference of potential between the chassis and the earth. And that difference of potential makes the oscilloscope, the piece of test equipment, sensitive to the static discharge. Also, to the difference of voltage with respect to ground. And this is very important to know. The first big mistake to do not blow the oscilloscope is to remove the ground. Because maybe I will learn in the video I can save the oscilloscope with the wrong connection with the alligator in the negative chassis connection of the test probe, but probably I will kill my oscilloscope myself just with one electrostatic discharge, that is thousands of volts. By saving the oscilloscope from 220 volts, I will kill it with my finger with thousands of volts. This is very important, guys, to know and to understand. Now that we realize for some reason the chassis must be grounded and all the equipment like this is my spectrum analyzer. If we are worried about to blow the oscilloscope, I will get more worried disconnecting the ground and to blow the spectrum analyzer, guys. Do you understand now the issue? Let's try to understand about electrical connections first. This is typically the kind of electrical connections we get in our home. Because many of us, we have the electronics laboratory in our house or our business in the center of the town, and we don't work with triphasic systems. In Europe, just to give you an example, most of the countries, we use the line 1, line 2, 220, and we feed the house with only 2 wires. In America, I saw many countries, they have the line 1 that is 110, one neutral, and has the protection earth. Other countries, or maybe the same country, they use 210s that could be 220, and the neutral is a center tap. if you pay attention to this picture, some of the break system for the electricity, the protection, the thermal switches, the distribution box comes with this piece of metal that is to screw to the chassis, and that will join the neutral with the protection earth. In some countries it's not allowed, in other countries it is a requirement. It depends the system. There are more systems than what I have here. Even there is one that is just a lifeline, and go yourself to find some earth somewhere and put it in your home. But this is the most basic ones. So in the house we have one line for 110, probably a second for the second 110 that makes 220. The neutral, we always use the darker color as high voltage live line in the mains, and the lighter color as the neutral. So same than this piece of metal here, some houses require to do that. This is the protection earth. And the first thing we are going to learn is in electronics, something that makes the difference between ground and protection earth. But keep in mind, in some houses, those two guys, the neutral and the protection earth, are going together. Got it? Let's jump to the next screen. After removing the ground, this is the second mistake people do. They use a Variac, a variable transformer. A variable transformer like this one, I use it in my electronics laboratory to keep all the tests I'm doing and measurements in category 1. Because if I connect directly to the main line, will be category 2. So I keep my job in category 1 using the Variac in between. But I use it for the boards, for the systems I'm testing, the device under test, not for the oscilloscope. I want to make that clear. What is the main problem with it? The main problem is, if I use the right polarization, okay, maybe it will help. If I invert the polarization, I'm doing absolutely nothing because I'm passing the live line directly to the oscilloscope. If I make a mistake with the ground, I will make the same problem blowing the oscilloscope, and the alligator with the ground probably will fuse itself. So the Variac is not a good idea. The second one is the isolation transformer. The isolation transformer will be good if there is no ground, because there is a polarized circuit for that, remember that. So you need the one that is not with ground. But we are in the same situation, guys. I open the ground, now the oscilloscope is floating. Any voltage I get is not with respect to ground, so there is a voltage in between. I'm not protecting the oscilloscope too, in case of the electrostatic electricity discharge. So yes and no. It will work probably, but I have problems in between. And why do you want to get a problem? Remember the engineering rule. If it can happen, it will happen. So let's learn more about the electrical connection in the oscilloscope. When I get a circuit like this, I want to know the voltage drop between this resistor or this other resistor or this other resistor. And from the oscilloscope I have the test probe, and the test probe, the alligator has to set the reference, and the tip of the test probe will get the voltage I want to know. So here is my test probe, and this is my alligator. And my alligator, I have to set the ground here. Let's remember already, probably the oscilloscope is already sharing the ground with my circuit because the power cable through the PE protection earth. So it gives me no options, and probably my alligator has to go to this place, and the test probe can touch any one of those places. But I cannot put the alligator wherever I want to make the measurement I wish. So now that I have cleared my options, let's jump to the next picture. Let's remember the clip alligator is not a problem. The problem is my knowledge. So stop looking to that picture, and now let's focus into think, to learn to analyze, and we will know what we do. There is here a circuit like the one we get everywhere. And there is the connection for the power, for the switch, some common mode coils, diodes, fuse, serial resistor somewhere, a chip that controls the pulsing, and a pulse transformer. In one side, one coupling capacitor, and the other one optocouple, the hot area and the cold area. And at the end of the day, we got something like that. So here is the place where I cannot place my oscilloscope ground without making a big mistake. Here is the place where I can connect my oscilloscope ground. So I got a schematic, something like this circuit, and let's learn to interpret where should I place the ground. Not because somebody will point me, put it here, please. We are going to do it because we will understand the circuit. This is the schematic of one circuit like the one we have. And the first thing we have to do is try to understand what is going on there. There is a hot area, there is a cold area, and we have to identify that. In one side we have the transformer, and the other side we have the optocoupler and probably the coupling capacitor. Now let's come back to the circuit. Transformer, the coupling capacitor, the optocoupler, and our barrier. Wherever the hot line is connected the main lines from the power supply. Wherever the cold area is, comes out the power to feed our electronics circuit. Got it? So that's easy so far. What is not easy is to learn to identify these two symbols. And here is where all the electronics guys, including myself, we make a tutti frutti. Why? We mix all that ideas. Because this is the normal ground we use to interpret in one circuit. This is the negative. And this other is the protection earth. But pay attention guys, because here, for this circuit, pay attention, is 5 volts, and its ground is the protection earth. So when I have this symbol, that means it's the negative in the circuit, and it could be a circuit that is fitted with the main lines, or it could be a circuit with batteries too. But when I get this symbol, that means this negative will come out from the equipment, test equipment, from the device under test, from the board we have, from the equipment we are trying to analyze, will come out a third wire that is the ground, the protection earth, to the electrical network. So keep it in mind, don't ever forget, and this is the main key we have to work with. To make it easier, we are going to give a little bit color to this image. Nope, this is not the same circuit we saw. Yes, we watched it, it was the same. But I want you to understand something different. When you watch an oscilloscope, you watch this beautiful panel with the wonderful screen, with graphics, with traces, buttons, lights, looks like a Christmas tree, nice present for everybody. And the BNC connectors, don't look at that guys. When you have to look to one oscilloscope, don't look at this. Try to understand the oscilloscope is a power supply. And you are going to apply one power supply to the other power supply you're trying to fix. So forget a little bit about the Christmas tree we have in front and pay attention to this. This is a power supply, yes, it's like the other one. What I want you to understand is from this power supply comes out, do you remember the symbol? A protection earth, a cable, and this cable in the oscilloscope is the same cable of my alligator. Got it? So easy was it? Yes. So my alligator is the same from the 3 cables entered in the oscilloscope, the protection ground, the earth. Now that I understood how my oscilloscope looks like, let's come back to the circuit I want to analyze. Here is our equipment under test, whatever we want to fix, review, and here is our oscilloscope. Both are power supplies. Easy. We say this is a ground, and we say this is the protection earth, right? The alligator, the cable from the little cable from the oscilloscope test probe. The point is, now that I understand that point, let's analyze quickly this circuit. I have the line and the neutral with 120 volts, 110, 110. So one goes to the switch, passes through the fuse to the common mode coils. The bridge rectifier should not be brown, should not be blue anymore, but I'm making that for us to understand this is the main lines, okay? So this circuit has a transistor that is switching and is joining this part of the coil of the transformer with the ground and return, so the transformer can transfer the pulses. In the other side, that was the hot area. In the other side, I have the cold area. And as I said, here I have the 5 volts, and the ground for the 5 volts is a center tap point, that is this same point. So is the protection ground. So now I have to make the separation between the concept I have of negative and the earth. Now that I understood that point, I can understand I cannot take the alligator and I can connect it in this point, because we'll be like joining the ground to the line. In some countries, let's remember, the neutral is joined to the ground, to the PE, to the protection earth. So we must keep everything polarized. Now that I understood this, guys, there are only 2 safe ways to do it right. One, if you understand the circuit and you can identify which one is this symbol, and I will show it to you very easy. Back to this board. This one is the symbol. It's touching the chassis. Same time on your oscilloscope. So there is no mistake when you take the alligator and you put it in the chassis. You are safe. That's all. Here there is a huge board. That huge, guys. Yes. But I don't care about the huge board, because everything that is under this border, I'm showing to you in the video. Under this border, everything is mainline. How do not make a mistake? If I have the alligator, where should I place the alligator? Here, there, in the other 2 maybe, because I have a lot. It's huge. Where to put the alligator? Very easy, guys. Put it in the metal, in the chassis. Look. This is my ground. Most of this power supply, everything that is here, is main line. Only this section and this little section here is the secondary, is the cold. The rest was hot. There is no place to put the alligator there. This is my safe area, and the oscilloscope, guys, is not made to do jobs in the hot area unless you have a differential probe, and that's something different. So your oscilloscope with this alligator is only for the cold area. Forget about disconnecting the ground, the variable transformer, the isolation transformer. Use a differential probe. That is made for the hot area and you will not make mistakes you don't have any worried about. This is the differential probe and is made for the hot area. This goes to the oscilloscope and this goes to the high voltage, to the main line, to the neutral, to the ground, I don't know, and you know what guys? I don't care, because with this device it will take care of all your worries. This is made for the oscilloscope to make tests in the hot area, even the cold one if you want. That's the reason why the ground in the oscilloscope is not removable. You need it. Even for this one you need it. This is the kind of device you must get. Try to save some money, they are not expensive, and it will protect your oscilloscope and will bring your electronics laboratory, your service, your repairings to the next level, because most of the problems we have in electronics is in the power supply and the high voltage, and with this device you can find how to solve it. There are also circuits that you can assemble yourself, and this kind of circuits will be the Postman differential probe circuit. Before to have something like this, I used to work with something I made myself. So the Postman differential probe, you can do it until you get a professional one. This, guys, is the proper way to protect the oscilloscope. Not disconnecting the ground. Disconnecting the ground is a fast way to suicide your oscilloscope with just an electrostatic discharge. Guys, I know I do not agree with the gurus, but it's not an opinion matter. As engineer, I have never been right or wrong. Physics, mathematics, numbers shows the proof, so I have no merit for that. I recommend you guys try to get a device like this, and this is the proper way to protect your oscilloscope, and that was the reason why it took me so long to get until this video. It's not so expensive, it's one of the best investment. Most electronics fails in electronic equipment is in the power supply or high voltage area. This is what you need to repair it. Thanks guys by watching the video. I hope it was worth it to you. Don't forget, the ground alligator goes to the chassis and you are done with everything. And this guy goes anywhere you don't care in the hot area. The knowledge is with you. See you next time. If it was worth it to you, do not forget to give a like.